This video is part of the MCAT chemistry video course. Subscribe if you'd like notifications about the release of new videos, and please visit ancientbrainstutoring.com for questions about one-on-one virtual MCAT tutoring. In this video, we're going to go over ionic compounds, which will just be the basics of them, so kind of just talking about what they are, and then we'll go over how to name ionic compounds. An ionic compound is what forms anytime you have oppositely charged either elements or molecules, and so when those opposite charges get close together, they will stick together because the opposite charges have an attraction to each other. So we call that an ionic bond anytime two oppositely charged species, which again is just an element or a molecule, anytime those oppositely charged species stick together, that is what an ionic bond is, and that forms an ionic compound. And ionic compounds can form between charged elements or between charged molecules or some combination of those two. So first let's look at when it forms between charged elements. So elements, when they have a charge, it's going to be based off of the group number. So here's a table on the left where we see that group 1 would have a positive 1, group 2 has a positive 2, and then we go all the way to the right on the periodic table to group 15, where that will have a negative 3, 16, negative 2, 17, negative 1. And the way that we assign these charges has to do with the octet, and that was covered in the previous video, so go watch that if that doesn't make sense. But you can also just memorize what charges are going to be associated with elements based off of their group number. And then the transition metals can have a variety of charges. So there's no one charge that you can associate with transition metals. And for many of those metals, they can have multiple charges. So sometimes a transition metal may have like a positive 2, but then in a different compound, it may have a positive 3. So the charge on a transition metal can vary pretty widely. So let's just look at these first two circles here and see how two elements would combine. So for example, if we have sodium has a positive 1 charge. That could combine with something that has a negative charge. So here we have chlorine. So chlorine has a negative charge, and those two would stick together, and they don't share any electrons. So that's going to be covalent bonds when they share electrons. For ionic bonds, there are no shared electrons. They only stick together because of the opposite charges. And then we get that charge from the periodic table. Now let's look at these next two circles to see how molecules participate in ionic bonds. So one of our species could be an entire molecule, like NH4, which has a positive charge. And NH4, we can draw the Lewis structure for because it's a full molecule and the atoms in that molecule are connected by covalent bonds. But then the molecule as a whole has a positive charge. So something like NH4 could combine with the chloride ion, or it could even combine with another molecule that has a negative charge. So either one, your cation or your anion, can be either an element or a molecule, but either way it has to have the positive charge for the cation and the negative charge for the anion. But anytime you have a polyatomic ion, which is when you have something like NH4 where there's multiple ions in the molecule and then the molecule itself has a charge. So anytime you have a polyatomic ion, you can find that formal charge through using the Lewis structure. But then there's also just some polyatomic ions that you're just going to need to have memorized. And we'll go over those in a future video over solubility. But just know that sometimes you're just going to need to have these memorized, and then other times you can find the charge through looking at the Lewis structure, and both of those will be in future videos. Something that's really important about ionic compounds is that the positive and negative charges are going to cancel each other out. And the way that happens is that the cation and the anion combine in proportions to where those charges are going to add up to be a total of 0. So if we look on our top left with those three circles here, let's say in the middle we have a cation that is calcium, and calcium is group 2, so it's plus 2 charge. And then let's say it combines with chloride. So chloride is group 17, so it has a negative 1 charge. So we're going to actually need 2 chloride ions to cancel out the calcium 2 plus charge. So anytime that you had a calcium chloride molecule, you would know that that molecular formula is CaCl2. And the exact same thing would happen if we were dealing with charged molecules instead. So let's say that our middle one is SO4 2-, and then it's going to combine with that ammonium ion, which is NH4 plus 1. So we would need 2 NH4s to cancel out the plus 2, to cancel out the negative 2 charge on the sulfate ion. So then the formula for this one would be NH4 and then parentheses to show that there's 2 NH4s and then SO4. And you want to make sure that these proportions are always in their lowest form. So if we look on the right here, let's see if we had something like Na plus Cl minus, Na plus, Cl minus. So this would be Na2Cl2. But you can see that there's a common denominator that goes into the 2 for each of those. So we want to make sure that we simplify it to where it's in the lowest proportion possible. So this one would just be Na plus and Cl minus for 1 each. So just NaCl. So the last thing we'll talk about is naming ionic compounds. And the first type of naming is for binary ionic compounds. And a binary ionic compound is when you just have 2 elements that are in the compound. And this isn't probably really going to be a question that comes up where you're required to do this, but it's just really helpful because it just increases your kind of like your chemistry literacy, and it helps to just read through passages and questions easier if you can recognize and name these compounds. So what you want to do is first remember that the positively charged one is called the cation, and then the negatively charged one is called the anion. So every time you're going to write the cation just normally. So for sodium, we just write sodium totally unchanged. And then for the anion, it starts very normally. So it looks like we're just writing chlorine, but then we just write IDE instead of the regular ending. So sodium chloride is our full name for this binary ionic compound. And you're just going to do the same thing for all of these. So calcium, we just write the cation normally. So calcium, and then the nitrogen is next, so we do nitride. And then this next compound has a transition metal. So nickel is a transition metal, which introduces kind of a new problem because nickel can have multiple charges. So we need to indicate with the name what the charge of nickel is. Because with these others, like sodium and calcium, we know what the charge is because sodium always has +1, calcium always has +2, but nickel we don't know. It could have multiple different charges. So what we do is we look at oxygen. Oxygen, or whatever the anion is, which here it's oxygen. So oxygen always has a -2 charge, which means if we have 2 -2 charges, the nickel would have to be a +4 to cancel those out. So then we write nickel, and then in parentheses, we do the Roman numeral 4. And then you're back to normal naming, so nickel 4 oxide. For this next part, we're going to work backwards, where we're given the name, and then we have to write the formula. So for magnesium oxide, we know that that's going to be MgO, but now we need to think about what our subscripts are going to be, so how many of each of those we have. And for this, you want to think about the charge, and magnesium is a +2 charge, oxygen would be a -2 charge, and this one's really easy because those are a 1-to-1 ratio, so for every 1 magnesium, you only need 1 oxide to cancel it out. So for magnesium oxide, we don't have any subscripts because it's just going to be one of each of them. So now let's do the same thing, but with a compound that has a transition metal in it. So first we know this is going to be just titanium, so Ti, and nitrogen. But now we need to figure out how many of each it's going to be. So titanium, since it has the 3, we know it's a +3. And then nitrogen, or because it's nitride, that is in group 15, which we know gets a -3 charge. So again, we end up with each of those, we just need 1 of each in order to get a total charge of 0. The last thing we'll look at is how to name ionic compounds when you have a polyatomic ion. And just remember, a polyatomic ion is when we have an ion that is not just a single element, and it has multiple atoms that make up this molecule, and the molecule itself has a charge. So for this first one, we have sodium sulfate. So sulfate is SO4, and it has a -2 charge. And the naming is pretty similar as what we did before. So we start with the cation is written totally unchanged. So sodium just stays how it is. And now what's different is whenever you have a polyatomic anion, you don't change the name. So we're not going to switch the ending to IDE. We're just going to write it as sulfate, and we'll leave it at that. So when you have the polyatomic anion, you actually just write the 2 names individually, so it just stays sodium sulfate. Our next example has the polyatomic ion as the cation, and then the anion is just an element. So how you write this one, you start with the cation name unchanged. So ammonium is what our cation is, and we just write that unchanged. But now since our anion is an element, we need to apply that rule that we did earlier where we change the ending to IDE. So the anion in this one is sulfur, so this one would be sulfide. So this would be ammonium sulfide. And for the polyatomic ions, we'll go over those in a future video as far as which ones you need to memorize. And then we'll also talk about formal charge and how they get those charges in the video that's over Lewis structures. For now, what I would do is just find the shortest list possible of all those lists on the internet that tell you what ions you need to have memorized for the MCAT. Just memorize the shortest one, and then that's probably going to be good enough for the test. And then once the solubility video comes out, I'll put on a list of ions that I think are the best ones to have memorized.